Hello everyone. Today we will discuss the magnetic flux. Magnetic flux is defined as the total number of magnetic lines of force crossing any surface of area A vector normally. Thus, magnetic flux is the total number of magnetic field lines crossing any area held normal to that. Thus, phi, the magnetic flux is represented by phi. Phi is equal to dot product of magnetic field and the area. So, dot can be replaced by the cos theta. So, phi is equal to BA cos theta. Now, if theta is 0 degree, so if here we consider a surface, there is the area vector outward drawn normal, and this is the magnetic field. So if the angle between this area vector and the magnetic field is 0 degree, then cos 0 is 1. Thus magnetic flux is B into A. That's the maximum value of the magnetic flux. So thus phi is equal to BA, and from here we can calculate the value of B, which is equal to phi divided by A. Thus magnetic field strength B is the magnetic flux per unit area, and is called magnetic flux density or magnetic induction. Now the SI unit of magnetic flux is Weber. So Weber is the SI unit of magnetic flux, and 1 Weber is the amount of magnetic flux over an area of 1 square meter held normal to a uniform magnetic field of 1 Tesla. Thus you can say 1 Weber is equal to 1 Tesla into 1 meter squared, because we know Weber phi is equal to B dot A. Phi, the SI unit of magnetic flux is Weber, then the magnetic field, the SI unit of magnetic field is Tesla, and the area, the SI unit of magnetic field is, the SI unit of area is meter square. So 1 Weber is equal to 1 Tesla into 1 meter square. Now the CGS unit of flux is Maxwell. Remember this, the CGS unit for magnetic flux is Maxwell, and 1 Maxwell is equal to 10 raised power 8. Okay, 1 Weber is equal to 10 raised power 8 Maxwell. Now the magnetic flux is a scalar quantity. Now going for the dimensional formula of flux, we know phi is equal to BA cos theta, and also we know F is equal to QVB. So from B we can calculate here B is equal to F by QV. So now substitute the value of B here. So flux we get B is equal to F by QV multiplied by A cos theta. So we know the dimensions of force, their area. So put the dimensions of the respective quantities, and we get the dimension formula ml2 t minus 2 into a raised power minus 1. A is for the ampere, and ml2 t minus 2 are the dimensions for energy. Thus SI unit of magnetic flux will be represented as phi is the Weber. Now this term represents the energy, and the SI unit of energy is joule. Now this is per ampere, so divided by ampere, the SI unit of ampere is the SI unit of current is ampere, so joule per ampere. Now we can represent ampere as coulomb per second, so joule per second divided by coulomb, and this joule per second is called the volt second. Okay, so we can joule per coulomb is the volt, and this is the second, so we can represent the unit of magnetic flux also as volt second.